Welcome back. This is an Aleks training video on using a rate law. I've given you a generic rate law in red at the top. We'll look at the specific one they gave us for the problem in a second. So basically a rate law, it's an equation because you have an equal sign, and it tells you how the rate of the reaction, how fast the chemical reaction is going to happen based upon the concentrations of each of the reactants. So if I've got two reactants A and B, or I've got three reactants A, B, and C, then the A and the B and the C or whatever will be in the rate law. And the concentration is molarity. So that's what the brackets mean. So when I say rate equals K brackets A, capital A, brackets B, capital B, what I'm saying is the molarity or the concentration of A or the molarity or concentration of B. And so the rate is how fast this reaction will happen based upon how concentrated your reactants are. Okay. The other parts of the rate law is the K. The K is a rate constant. Okay. And the X and Y tell you what power the reactant order is. So when you are asked a question, what's the reactant order? That's your superscripts. So the reactant order of A is the X. The reactant order of B is the Y. So let me go ahead and do that. This would be reactant order in A, and this is the reactant order in B. Okay, and that's the rate constant. Okay, and this is molarity of reactant. When you add up all the individual reactant orders, you get the overall reaction order. Okay, so the reaction order in A would be like a 1 or a 2 or a 3. The reaction order of B would be a 1, 2, or 3. Then you add those numbers up, and that'll be the total reaction order. Okay, so let's look at the first three questions before we go any further. The first three questions are saying, what's the reaction order of H2? Right, so go back to what they give us. We have the rate law here. So some kind of a constant times the concentration of A, so that's the hydrogen, and it's raised to the 1 power. Okay, so if there's nothing there, it's considered raised to the 1. The I2 is also raised to the 1. Okay, so this is saying what is the reaction order of H2? It's a 1. What's the reaction order of I2? It's a 1. What is the overall reaction order? You're going to add those ones together, and you're going to get 2. Let's look at question number 3. It looks really scary, but it's not. At a certain concentration of hydrogen and iodine, the initial rate of reaction was 0.92 molarity per second, or molar per second. What would be the initial rate of the reaction if the concentration of hydrogen were doubled? Okay. Now go back to the rate law. This is hydrogen to the 1 power. So if I double it, I'm just going to double this number, right? If it were squared, then I would have to take this number, double it, and then multiply that number times itself. I'd have to square that number. But since it's to the 1 power, it doesn't do anything. All I'm going to do, if I double hydrogen, I simply double the number that they gave you originally. Okay, so is that right? Doubled, yeah. So I'm just going to take 0.92 and I'm going to double it. And you're going to get 1.84 molar per second. Okay, and here's the last question. The rate of reaction is measured to be 96 molar per second when hydrogen is 0.97 molar and iodine is 1.3 molar. Calculate the value of the rate constant. Okay, all they did was give you the concentrations, and the concentrations, remember, is the number that goes inside the brackets. The brackets is your molarity. So they're going to give you the molarity. They told you what the rate was, And so the only thing left is the K, and they're asking for it. So you're just going to solve for it. So now look back up here. Here's your rate law. Rate equals K, H2, I2, all to the 1 power. So let's solve for K. K is going to be equal to, K will be equal to the rate, and then I'm going to divide by the molarity of the hydrogen, and then to the 1 power, and then also to the iodine to the 1 power. Okay, so just start filling in. So the first number they give you is 96. That goes here, 96 molar. And then the bottom one will be 0.97. That's the hydrogen, 0.97 molar. And then the iodine is 1.3 molar. So the K is going to equal 76.130055551. All right, so I've got 2 significant here, 3 here, 2 here. So I need to round to 2. So that's going to be K equals 76. Now molar is going to cancel with one of these molars, leaving you molar to the -1 per second. Okay, so molar to the -1 per second. Oh, they already gave you that. So that means that this is going to be 76 per molar per second. Sounds good to me.